It's absolutely insane that this inverter is as high quality and works so well for the price they're selling it at. I just can't believe it. This inverter is from Junbpaw, and it may just be the absolute best bang for your buck inverter out on the market right now. You can see here we're getting ready to do a bunch of testing and stuff on it. I've already done a little testing ahead of time, and this thing is insane. High quality, good price, and insanely quiet. Let me show you what comes in this box with this Junbpaw inverter. We've got a Cat 5e cable, got some documentation here, got some DC cables rated for at 2 gauge. And we've got this remote screen as well as on-off switch. And here's the inverter itself. Got a nice display screen here. We've got some fan ports here, and we've got these nice covers that come off, and there is where you connect your batteries. Negative here, positive here. And then on the other end here, we've got 2 AC plugs. We've got a multi-position switch. Here's where the remote screen plugs into, USB Type A, USB Type C. And then if you can see underneath that in that orange thing, we've got a terminal block to hardwire loads to. And just so you know, this is a slow charge, 2.1 amp USB Type A port, and just an 18 watt Type C port. So they claim that it will run over 100% capacity up to 115% for up to 60 seconds before it shuts down. 116% to 150% will only run 3 seconds before it shuts down. If you overload it to 151 to 200%, it will run for 1 second and turn off. And then anything over 200% is 200 milliseconds, and then it shuts off. If there's a dead short, it is going to try to shut down within 3 seconds. One thing to note is if you get the 3080 watt inverter, which is what I've got right here, they do recommend pairing two 2-gauge wires up with each other just to handle the potential current draw that this draws if you're using 12-volt batteries. Note that they only send you 1 set of 2-gauge cable. Guys, this is why I like Junbpaw inverters. They've really done a nice job with their construction. Just off the bat, notice all the heat sinks. That contributes to how quiet these inverters are. One of my favorite features, though, is the fact that if you pay attention, look right down here, right here, right here, they actually use solid bus bars to conduct the DC current to the inverter. They don't use wires, which I really like. Something else that they've done a really good job on this unit is now they're feeding the terminal block separate with its own wires from the board down here, and there's separate wires coming up to feed the 120 volt outlets. In a previous version, both the outlets and the block were being fed off the same wires, and now they're all feeding off the main lugs with their own wires, which is much, much better. So it's a very high quality, high frequency inverter. Ideally in your system, you guys want a battery that can handle surge loads well as the inverter. So we're going to see if both of these can handle starting a 15,000 BTU air conditioner. This thing has an insane surge. I will hopefully be able to capture it here on the Victron Smart Shunt. It may not be fast enough, but let's see what happens if we're able to start it or not. So I didn't quite capture it. Be able to start this massive 15,000 BTU air conditioner. It has just a crazy amount of surge. That is very, very impressive. Some of these inverters are just bonkers loud. Well, Junbpaw's got that figured out. So check it out, 1800 watts currently being pulled, and let you hear what the Junbpaw inverter sounds like. It's incredibly, incredibly quiet. So just for fun, I've hooked up the old Junbpaw inverter I had. You can see it doesn't have a screen, but I want to show you the difference in noise as well. So I've got the same loads, and listen to the difference. And to be clear, this old one is not obnoxiously loud or anything, but it is substantially louder than the new one. Go for the new one all day long. Super happy that they came out with this new and improved version. The other really nice thing about this setup is you have this remote control display. So you can just run it off a standard Ethernet cable. It comes with one. And if you simply flip the main switch down to the little remote icon, you can easily just flip the switch on this, and as you see, it boots right up, and you get a readout on the remote. So very handy if you're building a 12-volt system like in an RV or something and want to have this in your control panel. All right, I've got the Smart Shut pulled up on my phone, and I'm going to put a screen recording up on the screen here so you guys can see what's happening. Right now, nothing is turned on at all, and I'm going to unplug this heater just so we can see that the heater is pulling no power whatsoever. Something amazing about the Junbpaw inverter is how crazy efficient it is at standby. Notice that it is only pulling 6 watts of energy to be on standby. I'm going to show you a different inverter momentarily with a significantly higher standby consumption. If you're burning all your power trying to just keep your inverter on, that's a problem, because you want as much of the power as you possibly can from your battery to go to powering your loads. So finding a very efficient inverter is definitely the answer. I've got a big, huge, low-frequency 3,000 watt inverter. So technically, it's rated lower than the Junbpaw. The Junbpaw is rated to 3,080. This one's rated to just 3,000. It makes a racket when I turn it on. And as you can see, nothing is plugged into the outlet right here. Okay, I've got the Victron Smart Shunt hooked up here. And if you take a look and see, this inverter is consuming 51 watts in idle. So you're going to burn through a whole bunch of extra power just keeping this inverter on compared to the more efficient Junbpaw inverter. You're also going to spend a crap ton of money on an inverter like this. Low frequency inverters have their place, but the high frequency inverters are getting so good now, and they're so much cheaper. I think it's a no-brainer. Alright, we are going to do heavy load testing on this Junbpaw inverter quick. Dual cables hooked up to some bus bars, and then these two giant 12-volt batteries. These can easily discharge over 3,000 watts, so this should be plenty good power for this. And the heavy loads we're going to use is this electric space heater and this heat gun. Let's go ahead and fire the heater up here. Looks like that's around 1,300 watts. Next, let's go ahead and turn the heat gun on here. Over 2,000 per minute there. The cool thing about this heat gun is it's variable, so I'm just going to go ahead and increase the temperature a little bit. There's 2,500, 23. Let's give the heat gun some more power here. 26. Let's keep giving it more power. Heat gun can go more. There's the heat gun's max, 1,200. You can see it's glowing hot. Heater's still on high, and you can see generally we're holding steady at about 2,600 watts. It'll run this all day, no problem. Not even breaking a sweat. Alright, I need to figure out how to load this more. Hang on a sec. Alright, the heater and the heat gun weren't quite enough to give us the power we need, so I'm going to fire up the microwave here. Go 5 minutes. Alright, that's 1,400 watts. Let's fire up the heat gun. 2,800. Even still, we can't load this inverter all the way down. That's crazy. Okay guys, do not, under any circumstance, put heavy loads through a plug strip like that. It's not rated for this. However, I'm only going to be running this for a short period of time, and I just need a few more plugs on this inverter to get it up to its max, hopefully. 5 minutes on the microwave. Full power on the heat gun, 2,800 again, almost 29. Now we're going to hit this heater. There we go. And shut down. Nice. That's what we like to see. Overload protection. Turn this back on. Alright, let me see if I can get a little closer to that. Let's turn the heat gun down. Turn down to like 400 something, so it's pretty light. Let's go ahead and crank the heat as high as it will go. Okay, now let's go hit the microwave. There we go. 2904. Alright, let's go ahead and apply some heat to the heat gun. Oh, look at that. 3,100, 3,200, and it turned off again. So it has very tight tolerances, which is very good. It does shut down and protect itself well. Let's try one more time and see if we can get it close to its full rated output. Okay, we're starting out at 1,600-ish. Let's come start the microwave. 3,000, 2,900, 3,100, 2,900. It's right on the cusp. We've got the alarm, but it's still staying on. So I think this is about as high as we can get it with these loads. But it does hold a 3,000-ish watt load. It just makes a very loud beep when you get that close. Let's go ahead and shut the heat gun down. See, without the heat gun, we drop down to like the 2,900-ish watt range. That keeps it happy and stops it from screaming. So anyway, very, very good performance. It will go a little past what it's rated for, so long as it's not there for very long, and it is very good at protecting itself and shutting down.